Dear students, in continuation with the previous video of load shared by two transformers with equal voltage ratios. So here there are two transformers which are connected in parallel. Transformer having first transformer having resistance R1, reactance X1, impedance Z1. Second transformer having resistance R2, reactance X2, impedance Z2. Load shared by first transformer I1, load shared by second transformer I2. Both transformers they are supplying to the common load, and both transformers having the same voltage, that is E1 equal to E2 equal to E. Then its equivalent impedance of both the transformer is Z equivalent is equal to product of the two transformers impedance, that is Z1 Z2 divided by sum of the two transformers impedance, that is Z1 plus Z2. Okay, so now to draw the phasor diagram, so first we will consider the low terminal voltage as reference here, right? And this transformer is an inductive load, means always current lags to the voltage, so now first we will take V2 as the reference. Then from the tip of the V2 we will represent first transformer resistive drop. First transformer resistive, this is our first transformer. Resistive drop is I1 R1. Then 90° ahead to that will be reactive drop, that is I1 X1. Then resultant is I1 Z1. Similarly, the other transformer resistive drop is I2 R2. Then 90° ahead to that will be reactive drop I2 X2. Then the resultant of these two drops will be I2 Z2. Then this drop will be altogether represented as E2, and this drop altogether will be represented as E1, that you can see. Then from the tip of V2, first we will show first transformer resistive drop I1 R1, and 90° ahead to that will be reactive drop I1 X1. So resistive drop of first transformer, reactive drop of first transformer, its resultant is I1 Z1. So this is the dotted line, which is nothing but E1, right? Sorry, I1 Z1. Then similarly, the second transformer resistive drop, because both are having same resistive, same induced EMF E1 equal to E2. So from the same tip of V2, show for resistive drop of second transformer. Second transformer means this one. Second transformer resistive drop I2 R2. 90° ahead to that will be reactive drop I2 X2. First we show I2 R2, then show for I2 X2. Then its combination will be I2 Z. So from the tip of V2, second transformer resistive drop I2 R2, second transformer reactive drop I2 X2, and its combination is equivalent I2 Z2. So both transformers resistive and resistive reactive drop of first transformer, resistive reactive drop of second transformer, its equivalent is denoted by the dotted line. I1 Z1 is equal to I2 Z2. So vector sum of V2, vector sum of I1 R1, vector sum of I1 X1, that is altogether E1. So vector sum of I1 R1 here, E1 is equal to I1 R1 drop plus I1 X1 drop plus V2 plus I1 R1 plus I1 X1 is E1. Similarly, E2 is from the second transformer. E2 is equal to drop due to I2 R2, drop due to I2 X2 plus V2. That is first transformer V2 plus I1 R1 plus I1 X1 is E1. Similarly, second transformer V2, that is both terminal voltage V2 plus second transformer resistive drop I2 R2, second transformer reactive drop I2 X2, that is equal to E2. But here for both the transformers having its same induced EMF, that is E1 is equal to E2. So these are all voltages. And what about the currents? Currents is first transformer current is load shared by first transformer is I1, because here it is inductive load, means current I1 lags to the voltage V2. I1 lags to the this is the current shared by first transformer, which is lagging to the load voltage, that is this current shared by first transformer, load shared by first transformer lags to the voltage by certain angle phi 1. Similarly, load shared by second transformer, that is I2, lags to the voltage V2 by certain angle phi 2, because it is inductive in nature. So The vector sum of I1 and I2 is total load current I. That is what this vector diagram. So first transformer load shed is I1 lags to voltage V2 by an angle of phi 1. Similarly, second transformer load shed is I2 lags to the voltage V2 by an angle of phi 2. So vector sum of I1 and I2 is total load current is I. Okay. Now, as seen from the phasor diagram, I1 Z1 is equal to I2 Z2. I1 Z1 is equal to I2 Z2. Right. So that is all. Once again, I1 Z1 equal to I2 Z2. That is equal to total current I into Z equivalent. I into Z equivalent. Okay. So from this expression, I can write I1 is equal to I Z equivalent by Z1. Yes or no? I1 is equal to load shared by I1 is load shared by first transformer, because there are two transformers connected in parallel for the same common load. So if the load is connected for both two transformers, so how much is the load shared by first transformer and how much part is the load is shared by second transformer, that we are calculating here. So load shared by first transformer for the connected load is I1 is equal to IZ equivalent divided by Z1. So if you simplify further I Z equivalent by Z1, then it will be I into Z2 upon Z1 plus Z2. Similarly, I2 means load shared by second transformer. I2 is equal to IZ equivalent divided by Z2. IZ equivalent divided by Z2. So if here Z2 is missing, here you should write it as Z2. Z2 is not written here. So IZ equivalent divided by Z2 it is. So Z equivalent divided by Z2, if you simplify, then load shared by second transformer I2 is equal to IZ1 divided by Z1 plus Z2. Okay. So now considering the equation for load shared by first transformer, that is current I1, load shared by second transformer current I2, for these equations, multiplying both terms of above equation by voltage V2. So for this equation I1 and I2, on both the sides, if we multiply it with voltage V2 means load terminal voltage V2. So for I1 and I2, if we multiply it with load terminal voltage V2, then let us see. I1 V2 that is equal to already we are having IZ2. So IZ2 divided by Z1 plus Z2. This will be same. Just multiply V2. Similarly here for a second equation V2 I2, on this side V2 I1 Z1 as it is, IZ1 as it is divided by Z1 plus Z2. So now if we check this equation, V2 into I1, this is nothing but power equation, yes or no? So now, but V2 into I into 10 raised to minus 3 is Q, that is combined load in kVA. So this is combined load because V2 is the load terminal voltage. This load terminal voltage is it is common for both the loads, yes or no? So this is combined load V2 into I. But whereas this V2 into I1 indicates this is the load shared by first transformer. This is the load shared by second transformer. So V2 into I into 10 raised to minus 3 is Q, that is combined load in kVA. So based on this expression, V2 into I into 10 raised to minus 3 is Q. On the same lines, I can write the notation for V2 into I1 as Q1 because this is the load shared by first transformer. So from this kVA carried by each transformer is calculated as Q1. Q1 is equal to V2 into I1. This is denoted as Q1. So Q1 is equal to V2 into IZ2 divided by Z1 plus Z2. So it means that this, once again, this whole term V2 into I becomes what? Q. This will become Q. This will be as it is Z2 upon Z1 plus Z2. Or otherwise, if you simplify, this will be Q into 1 upon 1 plus Z1 upon Z2. If you simplify. Similarly, this will be load shared by second transformer. V2 into I2. I2, wherever it appears I2, remember it becomes Q2 now. So now V2 into I2 means this will be Q2. Similarly, V2 into I, here only single I is appearing, means this will be Q. This will be Q. So Q2 is equal to Q into Z1 upon Z1 plus Z2. Q2 is equal to Q into Z1 upon Z1 plus Z2. Or otherwise, it can be rewritten in the other form as Q into 1 upon 1 plus Z2 upon Z1. So this is the load shared by first transformer, that is Q1 is equal to Q into Z2 upon Z1 plus Z2. Load shared by second transformer is equal to Q into Z1 upon Z1 plus Z2. The above expressions are useful in determining the values of QA and QB in magnitude and in phase. So, this value of Q1 and QB indicates load shared by first transformer, load shared by second transformer. So, till here we should write in the exam. If they ask, they have an expression for load shared by two transformers and they load shared by two transformers connected in parallel with equal voltage ratios. Till here you should write the explanation. Okay. So here this is the load. So this is the load, and this load will be supplied from these two transformers. So how much is the load shared by first transformer for this load, and how much is the load supplied by this second transformer for this load? So that calculation is nothing but first transformer load supplied is Q1 is equal to Q into Z2 upon Z1 plus Z1. Similarly, load shared by second transformer Q2 is equal to total load combined load, that is Q into Z1 upon Z1 plus Z2. So it is very easy, simple to remember. Q1 is equal to combined load Q into other impedance Z2, because here Q1 is the load impedance of here load shared by first transformer means combined load of first transformer. Q1 is equal to combined load Q into other impedance Z2 upon sum of two impedances Z1 plus Z2. Second transformer combined load shared is Q2 is equal to combined load Q into other impedance. Q2 means other impedance will be Z1, Z1 upon Z1 plus Z2. This is how we can remember the expression. So till here you are supposed to write, if they ask the derivation, like explain or derive an expression for parallel operation of two transformers for load sharing with equal voltage ratios. Okay.